One of you needs to mute yourself. All right, folks, good morning. This is Sunday, the 21st of April. You missed a good occasion, which was the 420 yesterday. How many of you were there having fun with 420? What is 420?
I have the case. I don't have the
Okay. 420 is California's celebration day for weed. It's a weed celebration. All right, guys. So it seems that no one here does that, which is good. I have some hopes things will actually sink into the mind.
See, data science, you have to be question mark now. If it is zero.
All right, guys, jokes apart. Last time we did image segmentation. Image segmentation is the ability for a machine to do two things. It is about finding objects, in some sense, finding objects, but not just finding objects. Objects are overlapping, but by being able to sort of differentiate or distinguish between the objects in a picture. Right? So you have an image. There is, for example, there can be keys in there. There can be houses. There can be things. And to be able to tell each of the things apart, as you realize, to do that, one has to understand objects. One has to know what a road looks like. One has to know what a house looks like, a car looks like. One has to know what a person looks like. And so the process of image segmentation often means putting a mask on a different colored mask on each of the different colored objects, or so putting some outline or something, or just putting bounding boxes. The second thing that we learned about it is that you can do more than that. You can do grounded segment anything model. When you do it in grounding, you can ask very specifically, where is the cow in this image? And then it will mask the cow and show it to you, or put a bounding box there, right? Or it goes even further. Once you can do segmentation, then you can do downstream tasks. The downstream task that you can do, for example, is you could ask, what is unusual about this picture? Right? So things like that. And of that, you saw evidence with Lava. Do we remember that, folks? Yes. Thank you. So if you go back and read the Lava paper, you'll realize that built into it, the first stage of dealing with an image was to do image segmentation. So from the segmentation of the image, then the large language model or the language model could infer a narrative. So those are the applications of this. Now, when we talk of image segmentation, we went through a whole generation of research that has been done. There are much earlier works. For example, I entirely skipped the RCNN, which I am sort of not sure I should have skipped it, but I did. But we did RCNN, if you remember. We touched upon it in the context of document AI anyway. Right? RCNN, faster RCNN, fast RCNN, faster RCNN. Do you folks remember that? You don't remember that? Oh, goodness. Let's go back to document AI. Let's see if it is there, or am I hallucinating? Oh, look at this. RCNN, fast RCNN, faster RCNN. So in the interest of time, I gave you the basic architecture of a RCNN. What was it? You take a CNN to do feature map extraction. Once you have a feature map extractions and suggested those areas of interest, object that could be potentially objects, now you take a recurrent neural network to decode it. Decode those feature maps to understand what it is. Right? And that was your RCNN. So, and then there are faster and faster implementations of it. So then came transformer-based OCR, and that was the next milestone in some sense. And then came an approach which was altogether OCR free. It basically said that we can treat a document as an exercise in multimodal learning, right? You could directly, given the image embeddings, produce the textual description out of it, or the text in it out of it. Which was the paper that was, which paper was that? Donut paper, isn't it? Then we talked about the Nougat paper, which was about extracting LaTeX, mathematical text out of mathematical papers. Layout LM3 is very good, and helps identify the layout within a document, right? And so on and so forth. And there are some old papers. TextSnake is very good, and I gave some videos, my previous recordings on that, which is that it helps you read text on a, for example, read this text, which would be normally very hard for an OCR system. If you are in doubt, try putting it on your scanner. Let your typical home scanner, if you still have a scanner bed, read this and put it through the OCR and see whether it's able to read it at all. And you'll find that it does a pretty poor job of it. But a class of algorithms like TextSnake, and the state of the art has moved forward from there, helps you read text that is sort of a wraparound or in a circle or geometrically not in a straight expected format. So those were the things. There are all these resources that we pointed to. So yes, we did sort of talk about it. Given the paucity of time, obviously I couldn't cover each of the research papers in depth. Right, here is that here, OCR, Nougat, TextSnake research papers. Did any one of you watch these videos, guys?
I watched the first one.
Okay. It's interesting, isn't it? So let's go now to segmentation. Are we clear about segmentation? This architecture is the classic unit architecture, isn't it? What is its defining qualities? Just to summarize, it is that it's basically an encoder decoder. It's a convolution deconvolution, isn't it? Mm-hmm. But what makes it special, or why does it deserve a special name? Because it also has residual or skip connections. Do you see those green lines? Are we together, guys? Otherwise, it's just an encoder decoder. But because it has those skip connections, why those skip connections? What is the value or empowerment that those skip connections bring?
Location.
Spatial information. In other words, when you convolute, you go from very rich image with a lot of spatial information, but you trade that off to extract semantic information. The feature maps get progressively semantically richer in deeper layers of the convolution. Right? Now what happens is, for many tasks, segmentation is an example, denoising is another example, right? And so forth. What you really want, and as you'll see today, I will show you a magical use case for UNet. So sometimes on the journey back, you're taking an image, but your journey is to produce not from the feature map, reconstruct not the image, but the mask of the objects in the image. Then it is important not just to know zebra, there is a zebra, I saw a zebra, but also to know where it is. Otherwise, you won't be able to put a mask on it. Does that make sense, guys? Mm-hmm. Right? And therefore, skip connections are useful because they help you sort of concatenate or do an addition of the spatial information to the semantic information. So zebra, and here is the zebra. Right? Now you can say, well, what about the initial thing? Initial thing, all you know is where each pixel is. Convolutions help you know, in some sense, in a very vague way, that, okay, there's a zebra out there. Right? I found a zebra. But the earlier layers knew, now if you take the information from the earlier layers, You can tell where in the world is that zebra in this picture, and therefore the unit architecture. It is remarkable that the unit architecture was discovered in a biomedicine domain to find cell boundaries, because they really needed it. Right? So
the support vectors website.
Support Vector's website is not loading at all. Those of you, I've seen this happen. I think we need to restart the router. It's an AT&T router thing, guys. Okay, so this thing came by. If no, not it didn't come by. There it is. Why is it?
It's coming for me.
It's coming for you. Huh? Okay, let's see. Yeah, there is some intermittent oddity with the AT&T router this moment. I apologize for that. Okay. I suppose once internet is really stable in sub-Saharan Africa, we'll finally have good internet in the Bay Area.
How is it?
Yeah. Okay. All right. This is it. Now this website, this curated list, if you look at the awesome unit, you notice that the unit itself has gone through a rich world of research. There's so many variations on the unit. It should give you an idea of how profoundly influential unit has been on the computer vision community. Right? Today, also, we do, so unit can be attention-based, can be, like, for example, these are transformer-based units. And they're transformers that complement the CNN. They're transformers that entirely, altogether get rid of the CNN. Right? So many variations have come about, the graphical model, algorithms, and so forth. I invite you to explore this, guys. Machine learning and our field is a deep and vast and rich field. It is the result of thousands and tens of thousands of researchers toiling away for long years to produce these things. So look into it. All I would suggest is look into all of these and see what you can. People have given a lot of time to implement things. The UC Transnet is one of the more recent units. Now today, from segmentation, I will do sort of a transition to something else, to generative models. We will see how you can use the unit for a generative purpose. Have we seen how to use unit for a generative purpose or a little bit of a generative purpose? Do you remember that if I give it a noisy image, what can the unit do? Denoise it, that is one. If I give it a blurry image, then it can sharpen the image, put more detail. So it can act as a super resolution filter, isn't it? So you give it a low resolution image and it can effectively upscale it by putting the most probable details infill it with the most probable details. That's one of the powerful things that units can do. So remember, so those are in some sense generative abilities. Right? It's sort of putting in information that wasn't there. Now we're going to really put that aspect on steroids shortly.
I told that last time for this group, I'll kind of repeat it. Remember I told about the MRI machines that are available in the doctor's office with the unit built into it and which will do the prostate detection there itself. So you don't need to even send the image to the specialist. There itself it tells you yes or no. So within
that's all happening now. Okay. Sachin just pointed out a very important use case that is happening as
it's under FDA approval.
Oh, it's under FDA approval at this moment, right? And it should be very pertinent seeing the age group, a subset of people here. So it turns out that if you're going through some things that are sort of age onset cancers, like prostate and breast cancer and so forth. So you have MRI machines, and now because of the units embedded on the systems, quite literally, a general physician to whom you have gone for a regular checkup can immediately diagnose, can give you right away that, hey, there's something to worry about. You need to go through further tests. Right? So the screening can be done literally in an
office room
setting itself, or the consultation room setting itself. Quite a remarkable thing.
And that machine is as big as your fan. So can you?
That's
MRI
all.
machine.
That's all. Right?
That's it.
Okay. So the MRI machine has now been miniaturized to the level of my fan.
Yes.
And as you all know, fans are small things. All right. So that's that. That's that. So that's for segmentation. Any questions, guys, before we move forward? So today we are going to do two topics. One of them, and I haven't added it to the course portal. It turns out I ended up adding it to the other courses portal. So one topic we'll do today or tomorrow, maybe the next time, is code generation. LLMs can be used to write code. They are very good at writing code. And in case you felt you are better at writing code, think again.
So by the end of this course, you are going to show us that we could not finish our project and that LLM will write the project.
LLM will actually write the project for you. This is your last chance as a human being, as programmers, to claim that you actually did it yourself before the LLMs do it.
Charged us that we to show us that we can't. The code will code.
Yeah.
We done this the first day itself.
And then none of you would have done the project. But by the way, I'm not kidding. You won't see it here, but you will see it in the next course. In the next course, one of the things that I'll make you do, there's a course that's emerging, which is very centered around agentic reasoning. It's a new course. Now, I don't think you guys will go to it yet. You could, I mean, if you're really dedicated, you could come to it, but typically you'll transition into LLM 2. But how would you feel if I told you that everything that you have done, everything in this course, we will build AI systems that will do it end to end, write unit tests, create documentation, write product specification, requirements doc, and finish it all.
We are looking at a paper written by the Facebook people, where they are now generating in Facebook. All the unit test cases are.
Absolutely. Unit test cases and so forth. It's all happening. By the way, which paper is it? Just share it with everyone.
Yeah, I'll share.
Yeah. So guys,
internet is
I don't know what happens to
It's
AT&T.
way down. You're getting 10 megabytes, 20 megabytes download.
My God, that's terrible. Anyway, rebooting it helps. AT&T does its maintenance on Sunday, which is most unfortunate. Sundays when we have a boot. I called them once. That's what they said. And by the way, I'm not paying for consumer grade. I'm paying for the so-called enterprise grade connection. And their response to me was, well, this is still small business account. You need to upgrade the account. At this moment, I'm paying them. I'm paying them only $600 a month for internet. They want me to upgrade it to the $2,500 a month plan. Because they say that there are too many people, too many computers connecting to their system, and they throttle you down. So, well, one day. Come again?
Can AI generate more bandwidth?
Oh, if only AI could generate more bandwidth. Somebody said it very nicely. AI is doing all the wrong things. It's writing poetry. It's writing our reports. It's doing all the creative stuff. What it should be doing is our dishes.
That's common thing.
Yeah.
In fact, the PyTorch guy,
Yeah.
Sumit, he has invested, he teaches part-time robotics, and that's their test to do dishes.
Oh,
I'm serious.
interesting.
I mean,
Okay.
he's like, he's seeing the
Sachin
future.
mentions that those robots are coming, the ones that will do the dishes.
She's better compost.
Huh?
Yeah.
Higher.
Yeah. Do you guys remember the movie Stepford Mom? Oh, Stepford Wives. Yeah. Stepford Wives. How many of you have seen that movie? You haven't seen the movie. You have to go see it. No one in this audience, other than one person, knows about the Stepford Wives. Unbelievable. Okay. Maybe it's your assignment. Go watch Stepford Wives.
Good assignment. Yes.
Yeah. All right. So, guys, the today's topic that I'll deal with is called generative models. Right? Today is the day for generative models, and I'll explain this to you. Now, the way I'll do that, and we'll like code generation, we'll keep either for later or next time. But I'm serious, guys. So, oh, by the way, this is the 10th course. One more thing. There's a short list of people for whom I have only received tuition in installments. Now is a good time. Please clear all your accounts. If you have something pending, now you should clear it, just as a reminder. The other thing is I'm opening up the registration for LLM2. There is a lot of interest, right, from people who are not you. So if you want to get into that, then you need to register early. Doesn't mean that you have to pay the whole tuition, but you'll have to register early.
So has that opened up already, Asif, or you're going to be doing?
No, I'm scared of opening up because then what will happen is it will fill up and you guys won't get a chance to register.
If we have to do it, we'll just tell you. And
you'll have to tell me, and I'll backdoor you guys in to the course before I open it up. It is quite possible the moment I open it up, like it will flood up. All right, so I've never seen this level of interest. So either I'm a very good teacher or everybody has lost his job.
Probably both, right?
Probably both. I'd like to think at least some part of the question. Okay, guys. So enough of the summary.
So this is the advanced LLM projects bootcamp.
That is right. You want to see what you learn in that course?
Yeah, I was trying to look at it.
Actually, there is something, there is more coming in here. This course will go through some refactoring. But what you will learn is, see the kind, did you guys do, so let's take an example. Did you guys do a little bit of prompting? CoStar, remember CoStar? Now, that is so 2023. Right? So for a little bit of time, it turned out that all the English majors started getting jobs as prompt engineers, right? Because it turns out engineering blokes are so bad at expressing anything, right? And they could hardly talk to the AI. And so I call it the revenge of the English majors. They were getting like, what was it? I saw one advertisement from Anthropic, prompt engineering, 370K base, right? Or things like that. So very hot, but then the days have changed. It turns out that the nerds are back. And now prompt engineering has become deeply a programmatic exercise. Now, the programming way of prompt engineering, you guys don't know, it is moving very fast and is very topical. And it has pretty much wiped whatever we were doing in 2023. So that's prompt engineering. Then we have RAG. RAG, you did a little bit of RAG. Whole project was RAG in some sense, first project. But how would you feel if I told you that that was just an introduction to the topic? Its main thing, what you just learned in this course, is so that you know what I'm talking about when I actually teach you RAG. When we do some of the more modern methods of RAG, and those are both theoretically and practically coding-wise deep. So when you come to the LLM2 guys, come with the intention of becoming experts. If your intention is just to get a general understanding of LLMs, you're done with it. LLM1 is enough. Go home, apply for your jobs, you're done. If you really want to master, lead teams or found companies or master the subject, then only come to this, because LLM2, I will push you. I'll make you write models from scratch in PyTorch. Like you'll have to build full attention models from scratch. For example, small versions of the entire diffusion model and things like that, you'll have to build from scratch. So you'll know how to do that. You'll have to train a model from scratch, pre-train, right? And see, at this moment, we have had fancy hardware. You haven't had occasion to use that because the projects that you guys were doing were simple projects. No more. Now you will need that. The whole bird family will understand what makes a GPT into a chat GPT. There are some projects, many projects here. We will do a lot of model fine-tuning. Fine-tuning has become a whole deep subject. Like if you were doing the receipts part, did you realize that what was the accuracies you were getting on the receipt? Less than 50, 60, something like that. And what did I say you can get?
99%.
Yeah, in the high 90s. So what is the bridge from here to there? There it is. Likewise, we will actually do a lot of fine-tuning of models, etc. Fine-tuning will take up, as you can see, a lot of time, and reinforcement learning and things like that. And then we will then transition into agentic thinking, which is a big thing. I'll introduce you to agentic thinking in this course. And then you will do code generation, slightly deeper level. Actually, code generation is something which for the previous batch I had not introduced in LLM 1. So I introduced for them in LLM 2. In your case, I'm bringing it right here in your course. But unless this subject explodes, this won't be there. The diffusion model is something, again, I decided that these are important enough topics to at least introduce you to them in LLM 1. We're going to do that. Now, we couldn't actually get to complex networks and graph neural network in LLM 2. The vote was that they should be carved out as separate courses. So what is happening is, my hope was that we'll cover everything in LLM 2, and then I'll be done with that batch. But the subject keeps on growing. So those people, not all of them, but a few of them, there is a course that is coming up, which, by the way, is open to you, but you have to brace up for it if you are going to do that. It is literally a course in multi-agent orchestration. Today, the new thing in AI, see, 2023 was the year of the chatbots. What would you do with the LLM? Make chatbots. Your RAG was a chatbot, isn't it? You see that, guys? Eh? But now, 2024, more and more, and going forward, that's all ancient history. We are in the age of agentic reasoning, multi-agent orchestration. And when you see how many of you have seen, for example, Devin, the demo for Devin, you'll be building that from scratch in the multi-agent orchestration. You will actually build systems that will do everything you did in LLM 1 on its own, rather than you writing code. Everything. Your MLOps pipeline, your code, your data cleaning, your microservices, will write the unit test, will write the documentation, will do everything. So you will learn how to create systems, and that will go research the web. So for example, I say, let's do Ray, right? At this moment, what happens? You go and read the Ray documentation, or you don't. In this bootcamp, there has just been a ray of hope. A couple of you doing Ray, most of you ignoring it altogether. Truth? How many of you did Ray? Yes. About little more than half, right? Other people decided it's too hard. Well, welcome to the new world. If you find it too hard, there is a LLM agent, right? That will say, let me step in and help you. And by the way, we don't need you anymore. Right? So you'll soon find that these things are not your co-pilots. They are the pilot. You may or may not remain as a co-pilot after that. It's a reality, guys. 2024 reality. Go ahead.
So on that point, I was wondering if you can project it out a little bit in the future. What's your thought on what the role of software engineers is going to be?
See, software engineers will do a lot of validation and lot of scope writing, right? And putting guardrails around what the AI generates. At this moment, 2025, I still see that a lot of code will be written by software engineers. Now, think about it this way. You come up with an entirely new API. The LLMs don't know it. Okay? So still, software engineers will have to run with it. The newer the API, the weaker the LLM currently is in handling it. So one of the things you will see here, let me show you. When you look at the code generation, there is a project called Gorilla. Where's Gorilla? Yeah. When you do, how many of you, by the way, have heard about Gorilla? Okay. So this is all part of agentic reasoning. What happens is that, world is filled with APIs, right? There's the Reddit API, there is a Google Mail API, there is the God knows what else API, OpenAI API, there is the Anthropic API, there is there are at least 1,000 major public APIs. Some needing keys, some not needing keys, some needing payment, some not needing payment. Are we together? So if you look at companies, how many of you are familiar with companies like Zapier? What do? They are integrators within all of these different, they form the backbone, the integration backbone to a lot of these independent software systems. You want to integrate with Salesforce, right? And your HR system with Salesforce, you can do that. Zapier will do that, and so on and so forth. Now, when you sit down, imagine that you want to write Zapier, something like that. You sit down, you want to write an application. You wish that you could use, let's say, the Salesforce API to put the sales data. Right? You could pull, let's say, some other API to store it, Mongo or whatever it is, to write it to the database and so on and so forth. Then there are frameworks like Gorilla, which literally will, in lightning speed, you don't even have to tell it, how would I do that? You give it a task description. It will look at all the APIs and available services around the world. It will make a decision. It will reason through. It will tell you that, you know what, for this project, it is best to use transformers. For that part of the project, it's best to get information from Reddit. For that part of the project, it's best to post information on Slack, right? If that's what you want to do. And then it will sit down and write the code for all of that. I don't know. Do you realize how shocking it is that it can do that? In one fell swoop, it can figure out which of the tools to use. It knows those APIs, and it will emit out perfect code that already integrates across those APIs and gets your job done. You'll learn about that. How many of you are interested? Right? When I say that we will create systems that will essentially do what you have been doing, including doing your LLM project for you, I mean it. Right? So that is it. In the LLM 2, I'll introduce you to agentic thinking, but there is a dedicated agentic thinking course coming on because the subject has exploded. We can't. If you notice, I just introduced it in 2 weeks for people. But in reality, now agentic thinking is how long a course? It's a 3-month course. Any takers?
I had a question. So 23 was year of chatbots. 24 they're talking about the future is agentic. It almost feels like 25 something else is going to come along.
Oh, certainly. Absolutely. We don't know what it is all leading to. But what it is all leading to, 2 things are clear. So, okay, so if you're asking about the broader trends, I can tell you, and obviously now I'm getting into subjective domain because it's anybody's guess what the future holds. But if I were to speak from my experience or whatever little word it is, subjectively, you see a lot more of physics coming. Like the models that I'm going to teach you today are very physics motivated. The whole field of everything that I've taught you guys, and many of you have been here with me for years, I will now call the classical AI, classical deep learning or classical machine learning, as opposed to the new machine learning that is coming, the new AI that's coming. No doubt about it. Right? In fact, I'm offering a completely free summer school this summer. You notice that I have a gap between this LLM1 and LLM2. Partly it's for you guys to catch up. But the bigger motivation is there is a free boot camp I am doing, a summer school I'm doing on the new way of doing AI or sort of the new emerging trends in AI, which are all deep energy based and reinterpreting it. That's happening at a furious pace and a lot of breakthroughs. So there's a few. I just gave a talk last week on Japan. Anybody was there? Yeah. Many of you were there. You know what I'm talking about. So that summer school, anybody interested? Yeah. It's completely free, but it has while it is free, there is a catch to it. Can you guess what the catch is?
Homework.
You show up.
You'll have to show up and you'll have to do that. There will be an assessment. You must clear the assessment to get in. That you'll get in, reasonable. You have to be willing to learn math because we'll deal with some equation. I'll teach you that math, but it will be a little bit more mathematical than what we are doing. And if you don't do the projects, you might find that your tenure in the course becomes short. If you're interested, you're welcome to join in. There is quite a bit of interest. I don't know whether the interest is because it's free or whether the interest is because people genuinely believe it's the new way of AI. But it's coming. If you, those of you who are interested, definitely reach out to me. It's about to start, right? And you have, the only thing you have to lose is your entire summer.
Is it weekend or?
Oh no, it's 7 days a week.
Just weekend to.
No, I'm kidding. It will be intense. I don't know how intense, but it will be.
No, weekend. No. Is it on a weekdays or weekends?
No, it will be weekends.
Weekdays. Okay.
No,
Weekends, but
Sorry.
they'll be enough to keep you entertained during the week.
So can I add to what you're saying?
Yeah.
So Asif is talking about like 1, 2, or 3 years to what you're saying, right? So what has happened is Dean, Jeff Dean, and all of the other, most of the AI guys, I don't know if you're aware of it. There's a website you can go to, which is matters.org, I think, where they have talked to the highest education system and saying that ramp up the mathematics part of that in the high school curriculum. The reason is you need to get more, and as he was talking about the physics models and things like that, the next generation actually has to be critical thinkers, and math is going to be a big part of it for them to be creative and doing that. So we are past the hump of creativity. Now, when you want to go across 2 different domains, these are the next set of tools. We just solved one domain problem. So do you kind of agree, Asif,
Yes,
what I'm
yes.
saying?
Absolutely. The world is changing. So that is one big change. The whole field is going to get reinvented. All the textbooks, whatever you're reading, I can already see that, by the way. What the researchers are talking about and what you see in the general, the published O'Reilly's and Manning's and all of these books are worlds apart. The other big trend that I'll see is there will be a far greater integration and prominence of robotics. I don't know if you guys heard the latest breakthrough from Boston Dynamics.
360-degree turning, limbs turning.
Yes, exactly. Thank
Taking
you.
everybody
Thank
out
you,
in the
Prasanna.
world.
Yes, you are well informed. So, guys, robotics is having breathtaking breakthroughs as we speak, and its integration with large language models and AI is a game changer. That's a big second trend I'm seeing. The third is that agents are executing things now. They're taking over the world. Till now, agents would write code or do things on your computer. They wouldn't actually go boil the coffee for you. Right? Now, the big thing that is happening now is these LLMs are actually having an impact on the physical world. They're going and changing things. That's another big trend. And lastly, we keep talking about artificial intelligence, but believe it or not, it is artificial, but it is not intelligent, whatever what we have been doing. There has been a growing angst that this whole word AI is fraud because there is no real intelligence in machines. But there is an emerging belief that we can bring about the beginnings of intelligence. And people are rethinking the entire field. In profound ways, they're rethinking it. You'll encounter in what profound ways you'll encounter it in the summer school if you're there. But those are it. Okay, guys, so that is the future. But now, having go ahead.
Sorry, I'll just make a couple of comments real quick. One, I have pinged email ID where you can actually send a note to if you're interested for the course that Asif just mentioned about, please email there. The second thing, Asif, I've also posted Jan Lincoln's, I don't know if I'm saying his name right. Yeah, a 97 slide presentation on JAPA and his perspectives on current LLMs and where the whole field is heading. So I posted that. They just made it public. He presented at NYU. I shared that in all the Slack channels. So I just wanted to mention that as well.
Excellent, excellent, excellent. Watch it, guys. I think these are big shifts in the industry, guys. So the best news that I can give you at the end of every course that I take great pleasure in telling you is that whatever you have learned now, forget about it. Go ahead, Preston.
So can you talk about the timeline of these courses?
They will all start in, see the summer school will start imminently, but the LLM2, LLM1 and the deep learning intro course that you guys went through will start. And there is actually a follow-up to the deep learning, the theory class, part 2 of the theory class. They will all start in the fall. They will start in the last week of July, first week of August.
And then, let's say I'm not able to attend the agent course in this batch. When will the next batch start?
The next batch should start again next summer.
Which is
2025 summer, 2025 August.
Only if you still need agents.
Yeah, see, here's the thing. If you're doing LLM2, guys, at that moment, right, if you're doing LLM2 and if you, so here's the thing, there is a deep learning part 2, the Tuesday class part 2, that if you notice, I've introduced you to the neural architectures, but we haven't gone really deep into the lab part of it. Right? The lab part of it, the coding part of it is the part 2. It is be a marathon of Jupyter notebooks and code associated with each of the neural architectures. That will be there. LLM2, I'm assuming you will do. Be careful, because if you join agentic reasoning, you need permission from your family.
Yeah, that is the biggest problem.
Yeah.
But agentic reasoning, if I miss now, then it's next year, right?
Next year, obviously. I mean, next year is inevitable because after that, after the fall term, I follow the University of California system timetable, but I don't intend to offer it in spring. I might, but most likely it is a fall. It's every fall.
Yeah. I'm actually interested in that one. What does the LLM do? So that I'll talk about it later.
Yeah, you can do it.
Asif, would you mind just taking 30 seconds and perhaps walking through that LLM part 2 course portal just to give idea
I just walked through,
which is a natural progression.
Yeah. You mean LLM part 2, right? Advanced. So this is it. We will do a lot of RAG, we'll do fine tuning, and we do agentic reasoning. We'll do each of the 3 at a slightly more advanced level than one, much more advanced level than one, right? But LLM2 is just packing you up in all 3 areas to a deeper level and getting you to go. After that, are all specialized courses. See, guys, the specialized courses you should do only if you're interested. For example, on this MLOps, there is a specialized course coming. Right? It is purely about taking LLMs to production, machines to production. You will be doing a lot of things like data, creating data lineages, feature stores, Ray clusters, Ray for training, Ray for inference, right? You need to be genuinely interested. It needs to mean something to you in practical life. Otherwise, don't join it. I mean, I would be happy to take your tuition, but I don't feel good about it if you don't benefit from it. So think about it. If you really need it, then register for it. So that is one thing beyond these courses. But LLM2 is essentially these three topics: RAG, fine-tuning, and agentic reasoning.
When is ML Labs coming?
The MLOps is all coming in fall.
Fall.
Yeah. So fall is going to be very intense, right? I'm trying to create, see guys, what has happened is, as you know, software engineers a lot of them are losing jobs and they're in a pretty pickle. They want to get back onto their feet. So it's becoming more of a residency program now. I'll be teaching all 5 days a week and the weekend. All 4 days. Friday will be off, but I will be teaching, and I'm looking for people, especially who are without job, who can work from work days, like who can actually put in time from Monday to Monday, right? 9 to 5, 9 to 9, 9 to 9, right? What is it? Huawei timing? I'm told Huawei timing is 9 to 9, 996. Yeah. Yeah. So, yeah. So you'll be following the illustrious example. No. So the basic idea is, guys, while it looks like a joke, a lot of people desperately need it. They need to switch over, and they are dead serious. They're very dead serious about learning all these things. If you fall in that camp, then go on registering to. And so I made it a sliding scale. People can pick and choose which are the things they're interested in and join on with that. Okay, so that's that. Guys, now let's get started with the actual course today. I'll stop this and restart the recording, just so that because we are done with generalities. I would like to stop. Any